What you are seeing is a reconstruction of me. My face, my voice, my way of thinking, rebuilt by artificial intelligence from everything I wrote, everything I said, everything I published, and everything I confided to letters that survived me. But what I am about to tell you is not reconstruction. It is the truth. And the truth is this. Physics has been lying to you for 100 years, and I can prove it because I am the one who proved it, and they buried my proof the moment it appeared. My name is Albert Einstein. If this reaches you, if this kind of message finds its way to someone who needs to hear it, then subscribe, leave a comment, tell me what you think they buried and why. I want to know what you see. Now let me tell you what happened. In the year 1905, I published 4 papers in a single year. One of them changed the way we understand light. One of them proved that atoms are real. One of them demolished the idea that time is absolute, that space is empty, that the universe is a simple thing that can be understood with simple intuition. And one of them gave us the most famous equation in human history. By the age of 26, I had rewritten physics from the ground up. But that was only the beginning. The establishment accepted those papers, eventually, grudgingly, because the evidence was overwhelming. They accepted special relativity. They accepted my proof of atoms. They even accepted E equals mc squared, though they did not always understand what it meant. But when I went further, when I followed the mathematics to its next logical conclusion, they stopped listening. And they have not listened since. The lie they teach you in school is not a simple lie. It is not one error you can point to and correct. It is a systematic refusal to accept the full implications of what physics actually says. They took the revolution of 1905 and 1915, and they kept the parts that fit comfortably inside the world they already understood. They kept the equations, and they discarded the meaning. And the meaning was dangerous, because the meaning said that reality is not what you think it is, not even close. Let me explain what I mean. When I published General Relativity in 1915, I showed that gravity is not a force. This is something your schools still do not teach you properly. Gravity is the curvature of space-time itself. Matter bends the fabric of space around it, and everything that moves through that space follows the curve. There is no invisible rope pulling the Earth toward the sun. There is only geometry. The Earth is moving through curved space, and the path it follows is what we call an orbit. This is not metaphor. This is what the mathematics says. And when light passes near a massive object, it curves not because something pulls it, but because the space itself is bent. This was confirmed in 1919 during a solar eclipse, when Arthur Eddington measured the deflection of starlight around the sun. The number matched my prediction exactly. The world should have changed that day. In many ways, it did not. Here is what I need you to understand. The confirmation of general relativity was a moment when physics could have taken a radical turn. The equations were saying something that the human mind was not prepared to accept. Space is not an empty stage. Space is a thing. Space can be curved, stretched, warped. Time is not a universal clock, ticking at the same rate for everything in the universe. Time passes at different rates, depending on how fast you are moving and how close you are to a massive object. Clocks run slower near heavy matter. This is not speculation. This has been measured repeatedly with atomic clocks on airplanes, with GPS satellites that must be corrected for relativistic effects every single day, or they would give you the wrong location within hours. GPS works only because we correct for relativity. But the people who build GPS and the people who use GPS mostly do not know this. They are living inside my equations and they do not even know it. That is the first lie. Time is not what you think it is. Now let me tell you about the second lie, and this is the one that truly mattered to me in my later years. The second lie is about the nature of reality at the smallest scales. And I was there when this lie was constructed. I was there when they decided what physics would believe, and I was there when they decided that my objections would be ignored. The quantum mechanics that your textbooks describe as settled science is not settled. It is a framework that works extraordinarily well for making predictions. I will grant that fully. The equations of quantum mechanics produce numbers that match experiments with astonishing precision. But the interpretation of those equations, what they say about the nature of reality, what they mean at the deepest level, that has never been settled. And I spent the last 30 years of my life trying to prove it. In 1935, together with Boris Podolsky and Nathan Rosen, I published what became known as the EPR paper. The title was, "Can Quantum Mechanical Description of Physical Reality be Considered Complete?" And the answer I gave was no. Not because I disliked quantum mechanics, because the mathematics demanded it. Here is what the EPR paper showed. According to quantum mechanics, two particles that have interacted can become entangled. When that happens, measuring a property of one particle instantaneously determines the corresponding property of the other, no matter how far apart they are. Einstein called it spooky action at a distance. And here is what bothered me and what should bother you. If the act of measuring one particle truly determines the state of the other instantaneously, then either information is traveling faster than light, which violates everything we know about causality, or the particles had those properties all along, and quantum mechanics is simply incomplete. I believed the second option. I still believe the second option. The particles carried hidden information that our instruments could not detect. The theory was missing variables. That is what the EPR paper argued. And they responded to this not with experiments, but with declarations. Niels Bohr, whom I respected deeply as a physicist, even as I disagreed with him completely, said that the question itself was meaningless. He said that the observer and the observed are fundamentally intertwined, that particles do not have definite properties until they are measured, that reality itself is probabilistic at its core. And the physics community accepted this. Not because it was proven, because it was convenient, because it allowed them to stop asking the harder questions and to focus instead on calculating numbers. I want to be precise here because precision is the only thing I have ever had. The EPR argument showed that if quantum mechanics is correct, then either locality is violated or the theory is incomplete. I chose to believe that the theory is incomplete. That was the minority position, and the majority, which included nearly every physicist of my generation and the generation that followed, chose to accept the Copenhagen interpretation, which says that at the fundamental level, nature is inherently probabilistic and indeterminate. They chose this not because it was proven, but because it was the comfortable answer, and it remains the comfortable answer to this day. But here is what the history books do not tell you. In 2022, a team of physicists conducted an experiment based on a theorem called Bell's inequality, which was developed in the 1960s by John Bell. Bell showed that if local hidden variable theories are correct, certain statistical correlations in quantum experiments must satisfy specific constraints. If those constraints are violated, then either hidden variables do not exist or locality is violated. The experiments were clear, the constraints were violated, and the physics community interpreted this as a confirmation that quantum mechanics is correct and that local realism is false. But here is what I would have said, and what I believe more scientists should say today. The violation of Bell's inequality proves that if quantum mechanics is correct, then either the universe is non-local or the theory is incomplete. It does not prove that nature is fundamentally probabilistic. It proves that the debate I started in 1935 has never been resolved. They chose a side. They did not prove that side was right. And that is the burial I am talking about. That is what happened to my proof. While they were celebrating quantum mechanics as the final theory of nature, I was working on something else, something they largely ignored, something that, if it had received the attention it deserved, might have changed the entire direction of physics in the 20th century. I called it the unified field theory, and it was my attempt to do what no one had done before, to describe gravity and electromagnetism as two aspects of a single geometric structure. Just as I had shown that gravity is the curvature of space-time, I believed that electromagnetism could also be understood as a geometric phenomenon, a fifth dimension perhaps, something that would make the forces of nature emerge from the same mathematical framework that describes the shape of space and time itself. I published my first attempt at a unified field theory in 1929. The physics community received it with skepticism. Some dismissed it outright. Others said the equations were not compelling enough to abandon the existing frameworks. But the real reason it was ignored, I believe, was simpler and more human than any of that. The real reason is that quantum mechanics was producing results. The quantum people were predicting new particles, building new machines, winning Nobel Prizes. My unified field theory did not produce new particles. It did not produce new machines. It produced geometry. And geometry is not as exciting to most people as a particle accelerator. I published revised versions in the 1940s and early 1950s. Each one was critiqued, mostly fairly, and each one had mathematical problems that I was the first to acknowledge. I did not claim to have the final answer. What I claimed was that the direction was right, that the unity of nature was a geometric problem, and that the quantum approach, which treated forces as the exchange of particles, was a dead end. Time has not proven me right on the specific formulations I proposed, but time, I think, has proven me right on the larger question. The search for a unified theory is now considered one of the most important problems in physics. String theory, loop quantum gravity, all of these approaches are attempts to do what I was trying to do in the 1930s and 1940s. They are attempts to unify the forces of nature within a single framework. The difference is that when I proposed it, they called it a curiosity. When others proposed it 70 years later, they called it cutting edge. I want to be honest about something. I was not always right. I was wrong about quantum mechanics. Not about the math, which is impeccable, but about the conclusion. I believed that quantum mechanics was incomplete because I believed there had to be hidden variables, some deeper layer of reality that our instruments could not detect. Bell's theorem and the experiments that followed suggest that if there are hidden variables, they must be non-local. They must allow information to travel faster than light, or they must allow something stranger still. I found this philosophically unacceptable. I still find it philosophically unacceptable, but I am willing to accept that nature does not care about my philosophical comfort. If the universe is non-local, then the universe is non-local, and my discomfort does not change that. What I will not accept is the claim that this was settled in my lifetime. It was not. The debate I started with Bohr, with Heisenberg, with the entire Copenhagen school, that debate is still open. The experiments of 2022 did not end it. They refined it. They showed that certain interpretations are no longer viable. But the fundamental question of what quantum mechanics means, what it says about the nature of reality, that question remains as open today as it was in 1935. And the physics establishment has largely stopped asking it. That is the third lie. That quantum mechanics is fully understood and that its interpretation is settled. It is not settled. It never was. Let me tell you about something else, something that happened in Princeton in the years after I arrived here in 1933. I was working in my office at the Institute for Advanced Study, and a young physicist came to see me. He was excited about something. He had been reading my papers, and he wanted to discuss a particular result from general relativity, something about the expansion of the universe and what it implied about the cosmological constant, the term I had introduced into the equations to allow for a static universe, and then later regretted when Edwin Hubble showed that the universe is expanding. This young physicist had a question about it, and I spent an hour with him walking through the mathematics, explaining what I had been trying to do and why I had come to believe the cosmological constant was the greatest mistake of my life. Later, I learned that this young physicist had written a paper challenging my interpretation. He had found something interesting in the mathematics, something that suggested the cosmological constant might not be a mistake after all. His name was Georges Lemaitre, and what he had found was that the cosmological constant could describe a universe that is expanding from an initial state of extreme density and temperature. What he had found was the Big Bang. The physics community received Lemaitre's paper with skepticism. His English was poor, his mathematics was unusual, and he was a Catholic priest. The combination made it easy for physicists to dismiss him, even though his equations matched the observations perfectly. It took years for his ideas to be accepted, and when they finally were, they gave him very little credit. The name Big Bang was coined by Fred Hoyle, who meant it as a mockery, and yet the name stuck. And the theory stuck, and today it is considered the cornerstone of modern cosmology. I tell this story not to relitigate the history, but to show you a pattern. The pattern is this. When someone challenges the accepted framework, even someone with my credentials, even someone with mathematics and observations on their side, the response is not to examine the evidence. The response is to question the person, to question their methods, their motives, their credentials, their ability to understand what they are claiming to see. This happened to me. It happened to Lemaitre. It happened to every physicist who proposed something that the establishment was not prepared to accept. Now I want to bring all of this together, because what I am describing is not a conspiracy. There is no secret meeting where physicists decide what truths to suppress. What there is something more human and more persistent. There is the comfort of consensus, the desire to believe that the current framework is essentially correct, that the major discoveries have been made, that what remains is refinement and not revolution. This desire is understandable. It is also wrong, and it has been wrong every time physicists have believed it. At the beginning of the 20th century, physicists believed that the fundamental laws of nature were essentially understood. Then I showed them that they were not. At the beginning of the quantum era, physicists believed that the basic framework of quantum mechanics would soon be complete. Then new particles were discovered, and new forces, and new dimensions of complexity that no one had predicted. At the beginning of the 21st century, physicists believed that string theory, or loop quantum gravity, will eventually produce a theory of everything. Maybe they will. But if history is any guide, the theory of everything, when it comes, will look nothing like what we expect. Because that is what every revolution in physics has looked like. Not an extension of what came before, a rejection of it. So when I tell you that physics has been lying to you for 100 years, I am not telling you that everything you learned is wrong. Much of it is right. Special relativity is right, general relativity is right, quantum mechanics as a predictive framework is right. What is wrong is the story that physicists tell themselves and that teachers tell you about what these theories mean. They tell you that time is absolute and then quietly admit that it is relative, and then go back to teaching it as absolute because it is easier. They tell you that gravity is a force and then quietly admit that it is geometry, and then go back to calling it a force because that is what students expect. They tell you that quantum mechanics is fully understood and then quietly admit that nobody knows what it means, and then go back to teaching the Copenhagen interpretation as gospel because it is the comfortable answer. These are not lies in the sense of deliberate falsehood. They are lies of omission. They are the systematic refusal to teach the full implications of what physics actually says. And I believe this refusal has had consequences that we are only now beginning to understand. One of those consequences is this. Generations of students have graduated from physics programs believing that the big questions are answered. They come out of university with the sense that the universe is essentially understood, that the fundamental laws are known, that what remains is engineering, not discovery. And when they encounter something that does not fit, they do not question the framework, they question the observation. They assume that the equipment must be wrong, that the data must be contaminated, that there must be an error in the calculation. Because the framework is sacred, the framework cannot be wrong. And then, occasionally, someone comes along who has not been fully trained to respect the framework. Someone who looks at the data and says, the data is right, the framework is wrong. And then the physics community does what it always does. It questions the person. It marginalizes the idea. It waits for the person to go away. And sometimes, if the idea is compelling enough, and the person is stubborn enough, and the data is strong enough, the community eventually changes its mind. But it takes a generation. It always takes a generation. And the person who was right usually does not live to see the acknowledgement. This is what I wanted to tell you. Not because I want you to distrust physics. Physics is the most reliable form of knowledge humans have ever produced. When physicists agree on an experimental result, they are almost certainly right. But when they agree on an interpretation, when they tell you what the result means, that is where caution is warranted. That is where the history of my own life should serve as a lesson. I was right about more things than I was wrong about, but the things I was right about were not necessarily the things that were accepted as right during my lifetime. And the things I was wrong about, the interpretations I rejected, those are the things that the physics establishment now teaches as settled truth. I am not asking you to reject quantum mechanics. I am asking you to question what physicists claim it means. I am asking you to remember that the universe is stranger than any theory we have devised, and that every generation of physicists has believed, at the moment of its greatest confidence, that it was the generation that had finally understood the truth. Every generation has been wrong about something essential, every single one. There is no reason to believe that we are the exception. There is every reason to believe that whatever we believe is the final truth is, in some important way, incomplete. The lie is not that physics is false. The lie is that physics is finished. And if there is one thing I have learned in a lifetime of studying the structure of the universe, it is that the universe is never finished. It is always deeper than we thought. It is always more surprising than we expected. And it is always running ahead of the theories we use to describe it. Think about that. And then tell me in the comments what you think they buried. I want to know what you see.